So let me start this off. Here's problem 9. Daisy wants to put a koi fish pond. Let me just clarify this clearly a little bit. This particular fish pond is rectangular in shape. Okay, I didn't specify it here, but I'm telling you now that it is also rectangle in shape. And she wants to put this in her 9 foot by 7 foot rectangular backyard. So she got this not so big backyard, but she still want to put this fish pond, a rectangular fish pond in her backyard. And here's the other thing. It says along the inside edge of her backyard is a border. Now, do you know what a border is?
Yeah, it's like the middle.
No.
Well,
if I take a black marker and kind of shade around the edges of my paper, I just form a border. If I make it thicker, then I just got a thicker border. That's what it means. It's kind of like the perimeter around the yes, you're right. It's kind of like that, but it has a thickness to it. So think of it as a walkway around the fish pond. Okay, can you envision that?
Yeah.
So here's the rectangular backyard. You put a rectangular fish pond in the middle of your backyard, and you put cement around the fish pond to form a walkway, and that right there is the border. Okay, are we good with that? We all can see that, right? Because problem like this, guys, it's very important that you see, or at least form a mental image of what's going on. You've got to put yourself right there in the scene to see what's happening. So there it is. Okay, so the questions is, oh, by the way, the border itself is x feet wide. So notice I did not give you a specific number of feet. I just said x. That's kind of open. And here it says, what is the area of the largest pond she can fit in her backyard? Largest pond she can fit in her backyard. So with that information, I'd like to start off by help you draw a picture of this. So let's take a look. Here we go. Oh. Thanks. Okay. Good thing I'm still healthy. Otherwise, I would trip over and fall. All right. Thank you, Fernando. We're just like purposely leaving your backpack there in my walkway. Thank you. All right, that's fine. That's fine. Don't worry about it. All right, here we go. So here is her backyard. I'm going to use purple to represent this. So here is the rectangular backyard. Okay, any questions so far? So I'm just drawing myself a backyard. It is 9 feet by 7 feet. So I'm just going to go ahead and label the length and label the width. Please let me know if this is something that you can actually do when you read the problem. We can all do that, right? Okay. Another thing that we also know is she's going to put a rectangular fish pond in that backyard of her. So I'm just going to draw a pond right there, right in the middle of her backyard like that. So this right here, I'll just put blue in here to show you that this is the pond. And if you notice that the outside here is the walkway, is that true? And so when it's mentioned the border, that's what it's talking about, the surrounding walkway. And it says x feet wide. That means as you walk on the sidewalk, that's how wide it is, x feet wide. So it could be very thin or it could be very wide, but that's what's happening. So if you label that, it'll look just like this. The distance from here, from the edge of your backyard to the edge of the pool is exactly x feet. Any question there? But is that the only one?
No.
Where? Where else? On the other side as well. So x feet. And is that it?
Nope.
Nope. On the top two, right?
Yep.
So this is also x feet, and this is x feet. Okay, any questions so far about this blueprint that I have up here for you? Can you see what's happening?
Yeah.
Okay, so the question now is, what is the area of the largest pond? So basically I'm asking you to find the area of the fish pond.
It's rectangle.
Okay, but I know it's a rectangle, so at least we know that we're dealing with rectangle, therefore we need to set up a structure for it. What is the area of a rectangle? Okay, what is it again?
Width.
Length times width. Okay, so I'm going to write that the area of any rectangle is basically length times width. So my question now is, wait a minute. If I want to find the area of the rectangle inside, which is the pond, I need to find the length and width of that pond. is the length and width of that pond given to us? Is the length and width of the pond given to us?
9 feet by
Of the
7 feet.
pond.
Oh, wait, no.
No.
What we're getting here is the area of the backyard, right? We know that the area of the pond is smaller than that, but we don't have the exact length or the exact width. The only information that we have right now is the fact that there is a border of x feet wide around this pond. With that, though, however, it can help us get to the length and width of the pond. Watch what happened. Think this way. If I go ahead and take a little snip of this, and I take the length of this out, I'm going to show you, demonstrate a little bit. The length of your yard is exactly 9 feet, right? The pond is right here, right there. The thing that we know, that there's a walkway from the edge of the pond. Let me just show you here. Do you agree that from here to here, the edge of the pond, oops, okay, the edge of the pond to the edge of the backyard exactly is x feet. This is x feet, right? We know that this is 9 feet. How do we use this information to find or write the expression to represent the length of the pond?
9 minus x.
Just one x?
9 minus x squared.
X squared?
No.
Ooh,
X to the
interesting.
power.
Wait, let's think about this.
X to the power.
Let me ask you this question. Let's pretend that the sidewalk that I'm going to build is 2 foot wide. 2 foot. So instead of using x, I said, what if this is 2 and this is 2? Then what is the length of the pond?
5 foot.
I did not say x and y. I gave you a number now. If the sidewalk is 2 foot here and 2 foot here,
5 feet.
what is the length of the
5
pond?
feet. 7 foot. 5 feet. 5 feet. Wait, what? 5
Okay,
feet.
think. Here's the backyard.
Yes.
I'm going to build a sidewalk on both sides of the pond. The sidewalk is 2 foot wide.
5 feet.
Then what is the length of the pond?
5 feet.
Wait.
7 by 5.
How?
5 feet.
How do you get that?
5 plus 4 was 9.
There you go. So in other words, if you go back a little bit, don't you take 9, take away 2, take away 2? 9, take away 2, take away 2 is 5.
Yes.
But so now if I take away the 2 and write that back as an x, what do you write there?
9 minus 2x.
So 9, take away x, right? What is this going to combine into?
Negative 2x.
Negative 2x. See, the reason why I had to stop you because you told me x squared. Like, wait, we're combining like terms. This is x and x together is 2x, right? And you're taking away 2x. So in essence, is it true that it's 9 minus 2x that you're actually doing? Is that how you represent the length of the pond? So what did you just learn here? You learned that, hey, if I have to insert a number to make it easier for me to process, then do it. Then remove the number and put back the variable. You see what I'm saying? Remember how you used to replace the x with the 2, and then subtract it, and now I just have to replace the 2 with x back again, and that's how I got this. So can we take that information and write it like this? So the length of the pond is exactly 9 minus 2x. We're good?
Yep.
Can we use that information now to help us find the width of the pond?
Yeah.
What is it?
7 minus 2.
Very good. Because it's also 2 feet here, 2 feet here, right? The total length, total width is 7. So if you take away x and x on each side, that's 7 take away 2x, right? Just like how we use the length. So here we can write this as 7 take away 2x. Okay. Now that we have that information, did we just define what the length and the width of the pond is?
Yes. Wait.
Did we just get that? Yeah. So if we have the length and width of the pond, how do you find the area of the pond? Okay. So here it is. The area of the pond is length times width. And what is the length again?
9 minus 2x.
Okay. With the width.
7 minus 2x.
And you know why we're taking away 2x, right?
Yeah.
Because there's x over here and x over here. That's why it's 2x. See it? The total is 7, but we have to take 2x's out. Okay. What do we do here? How do we get this?
Like terms.
What do we do here?
The box.
The box. Thank you, guys. It's multiplying a binomial times a binomial. So it's a box of what dimension?
4.
It's 2 by 2. So here's the box. What do we put?
9 minus, or 9 and negative 2x.
Okay.
And 7 and negative 2x.
Okay. Can you help me multiply?
Yes. After I draw the box.
Yeah. Anyone?
I hate 9.
Why?
They look like eggs.
So, what's the first box gonna get you?
63.
63. Next box.
Negative 14x.
Negative 14x. Next.
Negative 18x.
Negative 18x. Next.
4x.
Square.
See that? See that? So next time when you do something like that, just kind of hesitate a little bit. Wait, is it x or x squared? Think carefully.
4x squared.
Thank you. Remember when we multiplied, we gotta have the power multiply. Oh, changed too. So you know, because we have x and x, that's x squared. Okay, any like terms?
Diagonal.
Diagonal. Okay. So how do we write this?
63.
63
3 plus.
minus
Minus negative 4.
minus.
Negative.
Wait, minus negative?
Minus 4.
Just minus, right?
Yeah.
Minus 32x, because this become a negative, so there it is, that's negative 32x right there.
And plus 4x.
Plus 4x squared. Okay, what question do you have there? This here represents the area of the pond. That is the answer.
So that's
Equation. Wait, but we have to find out what's the.
No, because we don't know what x is, right? So that means x could take it on any value. Does that make sense? So x could be 1 foot in width, or 2, or whatever. It doesn't matter.
Right.
But what I'm saying is, whatever x is, I just have to plug in this right here, and then give you the area of the pond right away.
Right.
Okay. But any question on that?
No.
Could you think of another way to solve this problem?
pattern.
No. I'm saying, if you look at this picture here, notice that we have to find the length and width of this pond. Is there another way to find the area of the pond without having to find out the length and the width of the pond?
My turn.
Think, just look at the picture alone. Remember what I did before with the rectangle deal, and I asked you to do something to it to get what I want? What if I just want to get this piece in the middle right there? What would you do to that rectangle paper?
Subtract.
Don't you put like 9 to 7?
No, don't worry about the numbers right now. I'm just giving you a rectangular piece of paper. I'm asking you, can you give me that little rectangle inside? What do you do?
Subtract.
Oh, okay, you cut what out?
You fold the paper and you
Okay, so you basically want to cut this out, right? So in other words, if you're going to give this to me, then don't you actually have the border left to yourself?
Yes.
You see what I'm saying?
Yeah.
If this is one whole rectangular paper, and you just give me the piece inside of it, the middle piece, then what do you have left? Just the border. So let's think about this a little bit. So in other words, in math, what you do is if you take the area of the whole rectangle outside, subtract the border, then you have the piece inside. Is that right? So can we still do it that way? Let me show you that it can be done. Because this is actually a pretty good way to do it, but let me just go ahead and minimize this for a moment and show you a little bit different approach here. So let's take a look at this. Okay, the other approach is this. We'll find the area of the entire rectangle outside, right? Do we know the length and width of the big rectangle outside?
Yeah.
Yeah.
9,
9 times?
7.
Yeah, so we know that, which is 63. So we got that area outside. I hope you kind of see
Yeah.
how it's played into what we're having here. Subtract what? What are we taking out to give me that pond inside?
Oh, subtract the 2 sides.
No, just think of it as a picture. I have the rectangle. What do you take away to give me that
The middle.
middle inside? I want the middle piece.
9.
What do you take away? Just tell me what you take away.
9x to border.
No, don't give me number. I'm not saying number right now.
The inside?
Take away what to give me the pond inside.
The border.
The border. So if you want to take away the border, don't you have to find the area of the border?
Yeah.
Which is just this piece outside, right? But you say, wait, it doesn't resemble any shape that I know. But do you notice that you can actually cut it like this, cut it like this, and it forms 1 rectangle, 2 rectangle, 3 rectangle, 4 rectangle. Then you can actually find the area of each piece like that, add them all up, and then subtract it from 63. And you still have your pond inside. You see, that's another approach to it. Is that true? So let me show you a little bit here. How do you find the area of this rectangle on the left-hand side here? If this is 7, and what is this here then? X. So isn't this 7 times x, 7x? So this right here is 7x, isn't it?
Yeah.
If this is 7x, then the right-hand side is also 7x. So we just got ourselves the area of the two rectangle on the left and on the right. All we need to do is find this little rectangle on the top and the rectangle on the bottom. Now this is a little bit trickier. If you think about this way. This rectangle right here, if you notice, has the width of x right here, isn't it? And what is this length right here? Did we just define it before?
Yeah.
What is it?
5.
What is this length right here? What is it? What did we define before?
9 minus 2.
There it is. We got that. No. 9 minus 2x. We defined that already, right? So this is 9 minus 2x, isn't it? So how do you find the area of that rectangle?
7 minus 2.
How do you find the area of that rectangle? How do you set it up?
Parentheses. 9 2x.
Okay, 9 minus 2x times x, right? Width times length, right? So what do you do here?
X times 9.
Which is 9x
And
minus 2x squared, right? How many pieces do we have?
2.
We have 2 of them. So don't we take this and times it by 2?
Yes.
Because we have this one and that piece on top, right? So if we times it by 2, don't we get 18x minus 4x squared? Okay. And don't we need to add back on this 2 rectangular pieces right here? What is 7x plus 7x? 14x, right? 14x plus 18x? 32x.
Oh, found it.
So this here represents the area of the border. So we take 63, take away the area of the border, then we'll get ourselves the area of the pond. So let me write it for you and show you here. So we got 63, take away the area of the border, and because of this negative, what do you do with this negative outside?
Change it positive.
We
Oh, you know,
distribute, don't forget there's a 1 in here. So 63 minus 32 positive 4x squared, right? So we write it, it looks like this. Is that right?
Yes.
So we can certainly write it like that, but if you actually compare it to what we got before, look at this. Is that actually the same thing? We got 4x squared, negative 32x, same thing. So what I'm saying, that we have different approaches to this kind of problem. Okay? But always think of yourself as, hey, you know, here's a piece of paper. Do something to it. So I'm going to give you another example right here now, just to demonstrate that and to see how easy it can be done. Look at this one. I have right here a rectangle once more. What's happening to this rectangle is I want to cut this out. I want you to find me the area of the shaded, the leftover. You see what's happening there? The green. That's what I want left when you give it to me. I know that this is a 6 and this is a 4. The width is 4, the length is 6. I also know one thing that I know that this whole thing right here is A, and this whole thing right here is B. Okay. Given this fact, how do you find the area of the shaded in green? What would you do? Describe to me, no mathly, just tell me, if I'm going to give you this rectangular piece of paper, and I want just the green back, what would you do? Cut what out? The rectangle out, okay? So I want you to go ahead and describe what you just said. I give you a rectangular piece of paper. A rectangular piece of paper has a surface, right? When we have surface, it's the area we're talking about. So when you translate it, you're saying, oh, so I give you the area of the rectangle. You said you cut out the smaller rectangle, which also means area. So cut out means what in math? Subtract. So is it the same way of saying, oh, that means I'm going to take the area of the big rectangle, cut out the area of the small rectangle, then what do I have left over? The area of the green. Is that true?
Yes.
Does this make sense? Can you do that? How do you find the area of the big rectangle? Which is?
A and B.
A and B. How do you write that? A, B. A times B, right? What about the area of the small one?
6 or 4 times 6.
Which is?
24.
Okay. Yeah. You don't know what A and B's are, so just that's all you can do. Write an expression for it. Area of the big rectangle minus the area of the small rectangle. And I got the leftover, which is the green piece. Right? Good. Okay. Any questions so far? Now, I'm going to change it up a little bit, and I'll ask you to draw another picture for me, but I want you to find the area of this. I want to use the same exact shape, but please make yourself another picture, in your notebook. What happened is, this time, I did not say that the width is B and the length is A. This is the only information I'm going to give you. This is A. Right there. This piece right here is B. You see the difference?
Yeah.
I did not say that the whole thing is A or the whole thing is B. I said this part here is A, and this part here is B. Find the area of the shaded. Go ahead. Do it. Let's see what we can do.
Alright.
I'm gonna give you a couple minutes here to process this, and so we can get started again.
Can you get on with the quiz?
Okay, here we go. So you can clearly see. You can clearly see that with this information, all of a sudden your entire width of this rectangle is what? A plus 4. And the entire length of this rectangle, because it's broken into two pieces, right? So this piece is 6, the other piece is B. A total of the two pieces will give you one whole length, which makes it what?
6 plus B.
6 plus B or B plus 6, right? Cool, so this is the length, and that is the width. What do you do with the length and width?
Multiply.
Okay, so multiply them. If you multiply that, you end up with this. A plus 4 times B plus 6, right? What did you just find here when you take A plus 4 times B plus 6? What did you find here?
Variables.
What is that?
Square.
The square?
Wait, no.
Box.
Grouping.
What box?
Use the box. The outside.
The outside box. Thank you. Because that represents the entire width. That's representing the entire length. So you are representing the area of the box outside, or the rectangle outside. What do you do with the rectangle outside now?
Subtract.
Subtract what?
24. Outside.
10. I mean 2.
Okay, what's the inside?
24.
24. So do you understand that when you take the area outside, take away the area inside, what do you get left? What do you get left? If you take the area outside, take away the area inside. Okay, very good. That's what we want. We want the area left in the green, right? So, for this one right here, what do? What is A plus 4 times B plus 6? How do you plan to solve this? Or simplify this?
Box.
A box, okay. What kind of box?
2 by 2.
A 2 by 2, okay. So here's 2 by 2. A plus 4, B plus 6. What is A times B? AB. What is 4 times B? What is 6 times A? Do you notice how I said the number first? Don't write A6, it's 6A. Don't write B4, it's 4B. Coefficients in front of variable, not the other way around, okay? Even though it's not wrong to write B times 4, but it's not the way we write it. Coefficients in front of variable. What is 6 times 4 here?
24.
Okay, so how do we put this whole thing together?
A.
Any like terms?
No.
No. So what do we write? AB plus
4.
4B plus 6A plus 24. So this represents that piece, right? And then now what? Subtract 24. Oh, interesting. What is 24 minus 24?
0.
0. So what do we have left? Just that. So what does that represent that I just circled? The shaded area. That's it. Okay, any questions so far? All right, thanks guys. That's it. Let me give you the question.